If the value of theta and phi are lying between 0 and pi by 2 and x is summation of cos to the power 2 and theta, where n is changing from 0 to infinity, and y is summation of sine to the power 2 and phi, where n is changing from 0 to infinity, and z is summation of cos to the power 2 and theta into sine to the power 2 and phi, where n is changing from 0 to infinity, then we have to find out the relation between x, y and z, and these are the options. And this question is from IIT JEE Mains 2021. Now let's solve this question. We have x, y and z. Now let's expand x. For n equal to 0, give the first term, and first term is cos to the power 0 theta, which is 1. For n equal to 1, give the second term, which is cos square theta. For n equal to 2, give the third term, which is cos to the power 4 theta, and so on. Now here x is sum of infinite terms in GP, where first term is 1 and common ratio is cos square theta. And we know that if we have GP, which is A plus AR square and so on, where A is the first term, R is the common ratio, then sum of infinite terms in GP is A divided by 1 minus R, where R is where the magnitude of common ratio should be less than 1. Here, if theta is lying between 0 and pi by 2, then the value of cos theta is also lying between 0 and 1, which means the common ratio is, magnitude of common ratio is less than 1. So, sum of these GP is 1 over 1 minus cos square theta. Now, from this x and 1 over 1 minus cos square theta, we can find the expression of cos square theta in terms of x. And this is, cos square theta is 1 minus 1 over x. Now similarly, we will expand y, and y is 1 plus sine square phi plus sine to the power 4 phi plus sine to the power 6 phi, and so on. Here y is also sum of infinite terms in GP, where first term is 1 and the common ratio is sine square phi. Here phi is also lying between 0 and pi by 2, so the value of sine phi is also lying between 0 and 1, which means the common ratio, magnitude of common ratio is less than 1. So the sum of infinite terms in GP is 1 over 1 minus sine square phi. Now this will give the expression for sine square phi, which is 1 minus 1 over y. Similarly, we will expand the expression for z, and first term is 1, second term is cos square theta into sine square phi, third term is cos to the power 4 theta into sine to the power 4 phi, and so on. This is also summation of infinite terms in GP, where first term is 1 and the common ratio is cos square theta into sine square phi, and the summation of infinite terms in GP is 1 over 1 minus cos square theta into sine square phi. Now we have the expression for cos square theta in terms of x and sine square phi in terms of y. So we will substitute cos square theta and sine square phi in terms of x and y in this expression. So this will give the expression for z, 1 over 1 minus 1 by x into 1 minus 1 by y. Now we will simplify this relation. We'll take LCM here, which is x, here y. So the new expression for z is 1 over 1 minus x minus y divided by x into y minus 1 divided by y. We'll take further LCM of these two terms, and this will be, LCM will be x and y, and the new expression for z is 1 over x minus 1 over xy minus xy minus x minus y plus 1 divided by xy. We'll further modify this expression for z, and this will give z equal to xy divided by xy minus xy plus x plus y minus 1, and these two xy are cancelled out. So the new expression for z is xy divided by x plus y minus 1, and we will multiply x plus y minus 1 with z. So this will give z into x plus y minus z equal to xy, and we will restructure this, and this will give z into x plus y equal to xy plus z, which is the correct relation. Thank you.